Hey y'all, today we're going to take a break from triangles and talk about some four-sided figures. So a quadrilateral is a four-sided polygon. We talked about that way long ago. This time we're going to talk more specifically about different types of quadrilaterals. Today we're going to talk about parallelograms. And what we're going to build throughout this next few lessons are sort of like a family tree of quadrilaterals. So if you start it now, you can add to it as we go throughout the lessons. So parallelograms is the first type. We're going to know some things about parallelograms: sides, angles, and diagonals. We call those properties or characteristics. So in order for a quadrilateral to be a parallelogram, the opposite sides are parallel. So these sides across from each other are parallel, and these two sides are parallel. Remember, arrows on segments mean parallel. And I put 2 for these to show that they're parallel to each other, but not to these two. Opposite sides are also congruent, which, if you remember, means that they're the same length. So these two sides are the same length, and these two sides are the same length. Similarly, opposite angles are congruent. So these two angles across from each other are congruent to each other, and these two are congruent to each other. And consecutive angles are supplementary. We talked about consecutive angles when we did parallel lines, and since we have parallel segments in parallelograms, we create consecutive angles. So I have a pair of angles right here. Those two add to 180. These two add to 180. And then if I go this way, this angle and this angle add to 180. This angle and this angle add to 180. So lots of supplementary angles. And then if I draw the two diagonals, that means the two segments that connect the opposite points of the parallelogram. So these two segments that intersect inside the parallelogram, they bisect each other, which means they cut each other in half. So this diagonal is getting cut into 2 congruent small parts. This diagonal is getting cut into 2 congruent small parts. So we can use those properties to solve some equations, write some equations, find some lengths. So here I have a parallelogram, and I want to find x. So notice I have the opposite sides labeled. Opposite sides should be congruent. So that means those two things should be equal to each other. So we're using the property to set up the equation, and then we just solve the equation like we have been all year and all last year in algebra. And we figured out that x is 4. So if I wanted to, I could plug back in here. 3 times 4 gives me 12. Plus 5 is 17. So each of these sides is 17 long. Again, I have a parallelogram. I want to see which property it is that I can use to help me. I have the 2 diagonals, so that means that the little pieces are equal to each other. So this little piece that's 6x minus 3 should be equal to this piece that's 4x plus 13. So I can write that equation. And I can solve to find that x is 8. It's important to point out that with these diagonals, these 2 pieces are equal, but they're not necessarily equal to the other 2 pieces in the other diagonal. So the pieces that are equal come from the same diagonal. Oops, skipped ahead. We won't pause, we'll do this one together since it's different. If I want to find x and y, first of all, 64 and x, they're consecutive angles, so they're supplementary, meaning they should add to 180. So I can subtract 64 from 180 to figure out that this angle X is 116 degrees. And then 64 and Y are across from each other. They're opposite angles, so since this is a parallelogram, that means that they are equal. So I got two U's for you to do. Use the properties of parallelograms. These are both parallelograms. And submit your answers on the Google form, and we'll talk about them in class.